Hi, assalamualaikum. Our studies is about factors that affect the profitability of US movie. So, our group consists of me, Nur Azima, Nur Balkis Dalila, Nur Naima, Armiza, and Shasha Nur Farhana.
Background of the study. This study was conducted to investigate what influences the profitability of a movie. The dataset contains data on 609 recent releases movie that includes the variables such as US gross in US dollar, the budget in US dollar, the runtime in minutes, and the score given by critics on the Rotten Tomatoes website. For the problem statement, the data is obtained from a survey to investigate the factors that affect the profitability of a movie. Nowadays, profitability of a movie no longer depends on ticket sales only. There are other factors that can also affect the movie profits. From these datasets, we believe that budget plays an important role to predict the number of ticket used. So, by having these datasets, it could help us to identify which are the factors that will affect the profitability of a movie. So, for the objectives, there are two objectives that we are interested in developing while conducting this research. These objectives are as follows. Firstly, to investigate the factors that are affecting profitability of a movie. Secondly, to determine the best model that can be chosen in predicting the US gross in dollar in a business of a movie.
Hi, my name is Nona Ima binti Zainuddin and I will continue to present about demographic profile. From the graph distributions of budget, the highest budget is $30 million, which is 32.5% of total movies. The lowest budget is $230 until $250 million, which is 1.25% of total movies. Based on graph distributions of runtime, the highest time is 102 minutes, which is indicate 31.26% of total movies. The lowest runtime of movies is 186 minutes. Next, we will see the graph of distributions of critic score. The highest score is 24, which is 11.8% of total movies, and the lowest score is 0, that is 1.2% of total movies. Now we will see the general fitness of the model. From the parameter estimate table, all independents are significant since p-value for all variables are less than alpha is equal to 0.05, where x1 is budget, x2 is runtime, x3 is critic score, and y is US gross in dollar million. So the linear regressions of the model is y is equals to negative 52.36923 plus 0.9723 5x1 plus 0.3x72 1x2 plus 0.64026 x3 plus error. Based on R square value, 57.72% of total variation in US gross, which is our Y, explained by budget, runtime, and critic score. So the other is 48.28% of total variation is explained by other factors. So based on table ANOVA, which is analysis of variance, the value of p-value of F test is 0.0001. This indicates that the model is significant.
Hi, assalamualaikum. My name is Armiza binti Azman. This slide I'm going to present about the model adequacy checking for the original data. So the things that I'm going to explain is about the linearity and then coefficient of correlation. The third one is the independence of error variance, normality of error terms, consistency of error variance, multicollinearity, and influential cases. So we go for the first slide, which I'm going to explain about the linearity between dependent and independent variables. As we can see here, these scatter plot metrics show about the dependent variable y, which is US gross, and independent variable of x1, x2, and x3, or we know it as budget, runtime, and critic score. So the scatter plot are used to determine the linearity of the model. Based on this, we can see that pattern of the scatter plot is approximately linear for all of the pairs of dependent variable and independent variable. Next, we go for coefficient of correlation, where it used to determine the linearity of the model. So based on this table, we can see that budget has the strong positive value, which is 0.683, and the runtime and also critic score has the moderate positive value, which is 0.366 and 0.346 respectively. We go for the next slide, which is independence of error variance, where it states about the Dubbing Watson. Since the value of Dubbing Watson is between the value of 1.5 to 2.5, therefore we can see that the error terms are independent. Next, we go for normality of error terms, where it shows that the graph of QQ plot and the PP plot. This is the plot of residuals, shows that the error terms are not normally distributed because all point does not lie on the straight lines. Therefore, the assumption of normality is not fulfilled. This is the consistency of error variance, where the purpose is to check the consistency. Where we can see that from this graph, the plot is not randomly scattered. Therefore, it can be assumed that the error variance are not consistent. Hence, we can see that the assumption of homoscedasticity is not fulfilled. Based on the table that I've attached, we can say that there is no multicollinearity in the models exist, since the variance inflation is less than 10 and the values of tolerance is greater than 0.2. Besides, we also can look at the Pearson correlation coefficient table to determine whether the multicollinearity exists or not. There is no pair of predictors has the value of the Pearson correlation which greater than 0.8. By referring to this figure, we can see that there are influential cases that will affect the regression model. This is because there are some values above the boundary.
Analysis Part B. So, first step is to do a transformation on independent and dependent variables. From analysis part A, we know that our original model has an approximately linear relationship and it has a problem on normality. Therefore, we will transform our independent and dependent variable. So, for our model, we will transform x1 and x2 to the power of 3 and x3 to the power of 4. And then we will transform y to log y. Step 2. Remove the outliers that are influential cases. So from a transform model, we will calculate the leverage value, positive value, and the effect value to find the outliers and influential cases. So here is the value that we get from the calculation, and then we will remove the outliers and influential cases based on this condition, and then we will run the linear regression again. So from there, we will get the parameter estimate table from the SAS. And from here, we will get the value for beta. So we will get the final model that consists of the transform variable and the value of beta from the previous parameter estimate table. General fitness of the model. So here is the ANOVA table for the final model. And from here, we know that the model is significant because the p-value is less than the alpha equal to 0.05. Next, we can see the model summary of the final model from SAS. So if we look at the table, we can see that the R-square value is 0.3465. It means that 34.65% of the total variation in US gross is explained by the transform variable, budget, runtime, and critic score. Another 65.35% of the total variation in US gross is explained by other factors. And then we can see that the adjusted R-square value is 0.3431. So we can say that 34.31% in total variation in US gross is explained by transform, budget, runtime, and critic score variables by considering 592 number of samples and 3 predictors variables. Testing the significant variables. Test the significant variable, we can see the p-value in the parameter estimate from SAS. So from here, we can conclude that all the transform independent variables are significant because the p-value for all the variables are less than alpha equal to 0.05.
Next, the model adequacy checking for final model. So there are 5 things that we will look into the model adequacy checking. The first one is the linearity. The scatter plot matrix shows the scatter plot of dependent variable y, which is US gross, and independent variables x1, x2, and x3, which are budget, runtime, and critic score. The scatter plot matrix will be used to determine the linearity of the model. From the figure shown, to determine the relationship between US gross and budget, we will look at the graph in the fourth row. And we can see at the first column, the graph is approximately linear. Next, we will determine the relationship between US gross and runtime, and also the relationship between US gross and the critic score. So for both relationships, we will look at the graph at the fourth row at the column 2 and 3. So for both graphs, we can see that they are approximately linear. Thus, the pattern of the scatter plot are approximately linear for all the pairs of dependent variable and independent variables. So the second one, we will look into the normality. This is the graph of QQ plot of residuals for the transformation y, which is log y. The QQ plot seems normal due to the separation of the point in the 45-degree line. Almost all points lie on the 45-degree line on the QQ plot. Hence, we can say that it has fulfilled the assumptions of the normality of the error terms. The third one is the consistency of error variance. So this is the graph of residual of predicted value for transformation y. So from our observation, we can see that the error variance is constantly lying between negative 0.5 and 0.5. Therefore, the error variance are constant, hence homoscedasticity does exist. Besides, we can also look at the graph of student task residual against predicted value after transformation. The error variance are constant because we can see that there are many observation lies above and below or beyond true standard error. Therefore, homoscedasticity does exist. The fourth one, we will look into the independence of error terms. To determine the independency of the error term, we will look into the value of the Watson. From the model, we can see that the value of the Watson is 1.869, which is in the range of 1.5 and 2.5. This indicates that the error terms are independent and no serial correlation problem exists in the model. Lastly, the fifth one, the multi-collinearity. Multi-collinearity problem can be detected by referring to the value of tolerance and variance inflation. We can see that the value of tolerance for variables x, which are budget, runtime, and critic score, are greater than 0.2. Meanwhile, the value of variance inflation, VIF, for all variables x is less than 10. This indicates that there is no multi-collinearity problem in the dataset after applying the transformation to x and y. So conclusions, we can say that the best model for this dataset is the transformation of x and y after removing outliers. This is because the final model is a good fit and adequate, since the p-value is less than 0.0001, which is less than the alpha value. The linearity shows that the graphs have positive relationship. The error terms are normally distributed and the error variance result is also consistent. There is also no multi-collinearity exists in the model. Therefore, we can say that the final model is a good fit model. That's all from our group. Thank you.